Welcome to a new test and teardown video. This time it is a huge instrument called Nicolet BE256. It's a data acquisition recorder system somehow. So I think it's gonna be able to record, store, sample some analog inputs. We can see all the different channels. So that will be inputs. We've got 4 channels here. We've got some other 4 channels here. And we've got some other 4 channels here. And I think we've got some crystal oscillator or some references stuff. That is some high voltage, really? What is that? I don't know. I've not been able to Google anything really, so I can't test it, like really test it, but I can open it and see what it is about. And don't you just love some of my sponsors when they come with products like this? I can reveal my wife is not super happy for this one. I think it has something to do with its size. Oh, this is big. Well, let's look a little bit. Yeah, let's look on the back. And here it says something about 450 VA. Oi. Frequency range is 45 to 400. So there's a switch mode converter in here, right? Yeah. Fuse 6, okay, anyway. Oh man, that is some nice stuff. I can't wait to open it. Oh my god, yeah, I know. My table is actually quite deep, so I was able to stuff it in, but there's no more space at all. So how about we just try and power it on, see what happens. 90 watts. And so this is the crystal. So something about a power on. That is something to do with temperature. So there's a temperature thingy in there, right? And then not a lot of other identifications of anything. That is optical inputs, right? But that is the crystal kind of. Oh, we got some funky stuff. What is that? Really weirdo signal here. So we've got 500 kilohertz of some really weirdo, unstable signals. What the heck is this? Huh. That is definitely weird. And let's check the other one. Yeah, that's exactly the same. No, that is 598 kilohertz. And this signal here is 500 and I don't know, 550 kilohertz. So what the heck is going on here? And then there's another output here. What are we doing? I really don't know what's going on here with this unit. I couldn't Google anything. So, and I'm a little bit scared. I'm a little bit scared about that one. So I'm definitely not going to stick my scope in that one. And what exactly is this? Maybe I should just take my voltmeter and check what that is before I stick in my scope. I think that's a good idea, right? I've been trying to play a little bit of Sherlock Holmes here. So I took my signal generator and I tried to input a signal on all the different inputs. And then I've tried to scope all the other connectors, but I don't see anything at all. No matter what I do, there's just no signals coming out of this thing. So, and obviously, it is just way too complicated to debug or to figure out what it is. So, what we can do is we can open it and see if there's any clues inside. What could it probably been doing? I don't know. We don't know anything, and since I can't really Google it other than this company made a few other units with the same name, number, and all that kind of stuff, and it's just data acquisition, data recording, something like that. But that's all I know. Google don't really want to help me here, so we got a little bit of indication here that's changed, and the power consumption is 84 watts, so it's not at all. Oh, okay, that works. So it's not a lot. And 0.4 watts in off. That's funny. So I better pull the mains plug completely and then try and yeah, let's look. So I took out all the modules, and I don't know if you can see this, but we're only halfway. So all those modules, they only occupy half of the size, right? And let's look a little bit on those modules. We got 3 different type of modules. We got 3 of those, and they are I would believe that is analog input, right? And those analog inputs, they go via some signal transformers or some sort of that, right? And then we got AD converters. Let's first look at the entire board like that. That's an op-amp, right? Maxim part there and analog devices. We got, that's definitely some AD converters, right? And then signal drivers and all that. So that will be the 4 different channels. And here we go with some Xilinx FPGAs, and they need a lot of RAM. So that will be the program, and we got even some more FPGAs down there, right? I mean, really? And they stacked the RAM on top of some other programmable parts like that one. And this is I think this is an 8-layer board. I've been looking a little bit on the different tracks here and stuff. It is beautifully made, really. Here you can see some more of the different layers. So we've got 2 signal layers and then ground planes. And it is okay to route signals layers in horizontal and vertical, and then you have your ground plane, because they don't really cross talk so much, because they only touch each other in a very, very tiny little spot. So that is a way to save layers. I kind of prefer to have a signal layer and then go in every direction and then have my unbroken ground plane, but that is just me, really. This is also an okay way to do that. And again, we had 3 of those, and we got 2 of the crystal something and some do not park, and maybe an input output thingy. And again, I have no clue what the heck this thing is doing, other than we got again 2 Xilinx, we got some RAM, more RAM, and yeah, programmable chips and stuff. It's just so annoying not to be able to Google any of that, really. That one could be a little bit interesting to look at, right? It's not a weak 20, no. It's an 8-bit processor from 84. Oh, is it really that old? Really? Oh my goodness, 95. And some other parts, right? Really? So, really? Why would they use some old crap like that? But anyway, that was 2 of those. And then we got the IEEE module. And that one is only a 2-layer board. Look how well this is made in a 2-layer board. Just to save money. Beautiful. So this is low speed, and it doesn't really matter that much with signal integrity when it's running quite low, and IEEE is not super duper fast and anything like that. Got all the line drivers and stuff to access the back panels, and then got our little IEEE interface here. Maybe it's a good idea to save some of those parts, because maybe they could come in handy repairing other kind of stuff. And then that is, no, it's not exactly. That is actually a little bit cool. The back panel, or the main PCB, is more or less the same as this, because you need the same kind of stuff here, right? But then look, all that is removed, and then there's added another board interface in-out board instead of the analog stuff. So all this analog stuff inputs to this, and then of course you can just interface it like that. That is quite neat. And oops, look at that. Water, fungus, moisture, damage. That is what happens. And here was this module I talked a little bit about briefly. See, this is optical inputs, and it's just those super slow speed signaling kind of inputs, and that's probably a clock latch or something like that, and then you get 8 bits, and that is definitely exactly what you see here. 0 to 7, and then 8 to 15 is not connected, so that is why you have those 8 like that, and then it goes to some line drivers, and then you're done. That is more or less what this module is doing. See, it's not connected to the back plane without, or yeah, it's only for power. So that is basically what we got of the modules. So I want to save those a little bit for later. Let's look inside the big boy down here. Oy, 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 oy. That is definitely a big bad power supply. And like I said, this is the space for the modules, and we even had more space in the back for the power supply. But of course this power supply could have been upside down, and then this whole box could have been a lot smaller. So what do you think about that power supply? That is some beautiful construction. I love it already. Wow, nice. October 95. It is that old. What is nickel cadmium? Oh my gosh. We got better backup batteries in here. Oh no. And look, they leaked a little bit down into the power supply. That is not so good. Oh no, leaky, shitty. Oh damn it. But at least the power supply didn't blow up. It's my fault for not opening before I power up stuff. And this is what happens when you do not obey your own rules. And by the way, look what I found inside here. I found a secret node. So it says it was prepared in 2008 by somebody here who signed it. I can't read this guy's signature, but it was prepared, and he says extra fan was built into this. So there's probably another fan somewhere, but definitely this is the only fan I can see. So this is what he did, and he changed some transistors and some FETs defect. Those are replaced with those and some other. Interesting. And then he's even writing all the different output voltages. Nice pointers here on the different voltages. I like this guy. Thanks a million times. Ha! How lovely is that? So it was hidden in here with a piece of tape. Lovely, man. Oh, I forgot to tell you this. Look at those thin wires we got in here. And here's the little temperature sensor. And we got 3 little temperature sensors mounted in here. And what do you see down there? We got 3 big bad power fans. So what I want to do now is I want to power this up and try and heat up one of the temperature sensors and see if the fan starts. It is actually quite quiet, but you can see here the fans are actually spinning real nice and slow, and the power supply got some status LEDs and they're all on, so that is great. So far so good. So let's try and play a little bit. Oh yeah. Can you hear the noise? This is of course real bad what I'm doing. I'm just taking my solder. So yeah, they all spin up, but only when they are really warm. Alright, so that definitely works. And this is the idle power or idle current consumption, right? Of the power supply alone. Oh my god. Oh, that case here is just driving me nuts. To get into that power supply here, I need to disassemble this entire case. Oh, it is absolutely beautiful, this case design. I really like those rack kind of units here. And you know what? If you got a real good saw, you can actually cut these and then redesign and reuse this case. And you can also cut the side plates and top plates and whatever, right? So yeah, there could be a new cool product coming up in this case. It is really a nice reusable case. I removed everything here from one side, and now it's super easy to see what we're doing here and what we got of good things. So that power supply is definitely super duper big and nice. And that's the backplane in 2mm PCB for stiffness and stability. The 3 big fans mounted on a plate and a filter, of course, so that is nice. And I think actually I need to reuse it exactly as it is with the fan and all that kind of stuff. So I think I will leave this as it is and then just remove the stuff here, because I want to mount a big, powerful 2 kilowatt transmitter tube right there. And then some of the power supplies and stuff for the grids and the filament back here, and then the high voltage stuff needs to be in another power supply case. But I think that is a good idea. I just don't know if they are powerful enough, those fans, because I really want to pull a lot of air, but that is another project. But I want to take out the power supply. That was my main intention here. It's a little bit difficult. I hope I can figure out how to assemble this again when I get time to go on with my next project. I think I need to remember something about those square nuts here. So this also adds a lot of stability in the case when there is this support here to the handle, right? And then it goes all the way to the back, and then this center board, or the main frame board here, right? See what happens. It really adds a lot of stability with this one. And then we got these as well. And the power supply is mounted on that. And of course I can move this up or down to create whatever kind of other level I want. And this one can of course be here or here. So yeah, it's a very flexible, reusable case. I think it is definitely worth it. I'm carefully investigating how I can reuse as much as all this cool mechanics as possible. I of course also want to experiment a little bit with the fans, but what I see here is it's 12 volts, only 120 milliamps. So that means very silent, very slow-mo and all that kind of stuff. It's very good for small electronics products like this. But what I want is something completely different. So yeah, I can reuse the hardware, but I need to change the fans. They are definitely not for my kind of project. But here we see the fan regulators, and they are of course controlled by the temperature sensors, all analog. We got a little bit of voltage references, voltage measurements and kind of stuff like that, I guess. And then this communicates back to the power supply most likely, right? What else is this doing down there? I don't know. Yeah, maybe we got some signals and stuff. I mean, it's really beautifully made, I must say. I also kind of like the single point ground to chassis here. That is also correctly done, and very short chassis and mains filter. There's a double mains filter here, so that tells us a little bit about what kind of noisy stuff this is, right? This is a shielded mains cable going to the main on-off switch. Oh, and that one is so tough. And while we are playing a little bit with the fans, as you can see here, the blades, they suck in air and blow it up the unit. And this is of course the down plate, and then we got the filter. But what you see here is the distance to the metal and to the air intake holes. It's almost touching the metal. I hope you can see what I'm saying. Also, if you look at this side, you can see the blade to metal here is just almost zero distance. And that is of course not super duper smart. So if you want to make a quiet system with your fans, then try and lift them up a little bit, like this distance away from your air intake holes, and then you will see you get a much quieter product, if that means anything to you. So that's a little trick for free. I think I will call it a day or a night. What is it? Oh my god, it's so damn late again. Oh no. There's a little bit of weird things about this power entry here. Remember we had this filter with the entry to the filter going here. We also got some mains voltage selection kind of thing here. And that is actually a little bit funny because the power supply is looking a little bit like this. So line and neutral, that's the main entry. But then we have voltage selection done here. So that looks a little bit odd. I think I'll go and double check the specifications, but I think also I will put this power supply in its own separate video because I think it's going to clog up this video. 5 outputs, and let's just see what this baby can do. 5 volts, 50 amps, huh? That is something. So it's a 350 watts. And here you go with the number and all that kind of stuff. Hopefully I can look this up. But anyway, I think I got what I came for. A super nice reusable case. And that is actually all I can use. I will of course also consult some of the modules, especially for cool and sexy AD and DA converters and something like that for some of my funky analog products. I think I'll definitely go and look them up and see if they can be used more or less as the circuit is for some funky cool prototyping and stuff like that. We got the analog front ends and all that, and then the AD converter, and looks a lot like it is 12 bits. Look at that. Here we got the 8 and then 4 more. So definitely easy to reuse. But anyway, I would like to say good night and thank you very much for watching. Hope to see you soon again. Bye bye.